this video, we will be discussing about jump game 2. You are given a zero index array of integers nums of length n. You are initially positioned at nums of 0. Each element nums of I represents the maximum length of a forward jump from index I. In other words, if you are at nums of I, you can jump to any nums of I plus j, where j is between 0 to nums of I and I plus 1 is less than j. Return the minimum number of jumps to reach nums of n minus 1. The test cases are generated such that you can reach the last index. So what they are saying is that in the input, we are given an integer array nums. Now in this, each element denotes that what is the maximum length jump that we can take from that particular index. So basically, if I am at index 0, here the value is 2. Then that means from here, I can either make a jump of length 1 or length 2. At max, the length of my jump can be 2. If I am at index 1, here the value is 3. So then that means either I can take a jump of length 1 or length 2 or length 3, right? Now, initially we are positioned at index 0, right? And we need to reach the last index of our array, right? Now the test cases are generated in such a way that it is always possible to reach the last index. Now we need to identify that how many minimum number of jumps are required to reach the last index from the index 0, right? If you see, for reaching this 4, we are having multiple ways. From this 2, we can go to this one, then here and then here. So it will take a total of 3 jumps, right? Other possible ways, from 2 we go here and then we take a jump of length 3 and we directly go to the last index. So here the number of jumps that we have taken is 2. So 2 is minimum. So our answer is going to be 2, right? So how can we solve this? So one of the basic idea that comes to my mind is that let's try to check all the possible ways of reaching the last index, right? And in all those possible ways, whichever way is giving me the minimum number of jumps, that is going to be my answer, right? So for that, for identifying all the possible ways, obviously you are going to apply recursion, right? So what you will do is, in your recursion, you will have the current index, which will be I. Initially it will be 0, and the other thing that you will have to maintain is the number of jumps that you have done till now, right? So let me denote it with j. So the number of jumps will also be 0 initially. So when you are at index 0, here the value is 2. Then that means from index 0, I can either go to index 1 or to index 2, right? In both the ways, my number of jumps will be 1, right? Now, when I am at index 1, the value is 3. So from this index, I can go to 3 different indices. So one is I can go to index 2 or to index 3 or to index 4, right? Here the jumps will be 2, right? Then when I am at index 2, so the value is 1, right? So I can go to index 3 and my number of jumps will be 3. Then from index 3, I can only go to the next index, that is index 4. So I will be 4 and number of jumps will be 4. So now we have reached the last index. So this is one of the possible ways of reaching the last index, and the total number of jumps here are 4, right? What we did was, from 2 we went to here and then from here and then here and then here. So the total number of jumps were 4, right? Then if we see in this particular case, when we are at index 3, right? This was the index 3. From here we can only go to index 4. So I would be 4 and the number of jumps would be 3, right? Then here, if we see, we are already at the last index and the number of jumps are 2, right? And similarly, you can draw the recursion tree for this case also. At the end, we will see that for every I equals to 4, the minimum jumps that we are getting is 2. So this 2 is going to be our answer, right? So let's quickly look at the code of this approach. So since we will be applying recursion, and in that we will be needing the current index and the number of jumps that we have done, so we will create a helper function, right? And that helper function will return us the minimum jumps. So let's name it helper. In this helper, first we will pass the index, which will be 0 initially, then the number of jumps, which will also be 0 initially, and then our nums vector, right? And this will return us the minimum number of jumps, so we can return whatever we will get, right? Now let's create this helper function. This will return us an integer. It is receiving the current index, then it is receiving the number of jumps, and then it is receiving the vector nums, right? Now inside this, what is going to be the base condition of our recursion? When our index reaches the last index, right? So if at any point the index becomes greater than equals to nums.size minus 1, in that case we can return the jumps that we have right now, right? Otherwise, we need to identify the minimum jumps, right? So we have to check that from the current index, that is ind, at what all indices can we go from this index, right? And from all those indices, what is the minimum jumps that you are getting, right? So first, let's create a variable mini and we will assign it int max, right? Because we want to take the minimum. Then we will run a for loop of I starting from 1 and going till nums of int, and we'll do I plus plus. So basically, whatever is this index ind, in that we will add this I to get the further indices, like all other indices where we can go from this index. That is why we have started our I from 1, because if I will start my I from 0, I will remain at the same index, right? There's no point of staying at the same index, right? So now in this, I need to identify that what is the minimum number of jumps that I am getting if I go from index int to index int plus I, right? So what I will do here is in mini, I will take the minimum of mini, comma, helper. Inside this, my new index will be int plus I, right? And then my number of jumps will be increased by 1, and then I will pass the nums vector, right? So this will give me the minimum number of jumps, and at the end, I can simply return this mini, right? So this will give me my answer, right? Let's run this. So now the time complexity of this code will be somewhere around n to the power n, right? And given the constraints of the problem, this is not going to get accepted when you will try to submit it. It will give you a TLE, right? So what comes to your mind next? That let's try to optimize it further. So when we want to optimize a recursion, the first thing that comes to our mind is applying memoization, right? So in that memoization, we would be needing a DP vector, right? Now, what are the things that are changing in our recursion? So one is the index and one is the number of jumps. Then that means we would be needing a 2D DP, right? So what we'll do here is, first we will take the size of the array in n, and then we will create a 2D vector named DP, right? The first index will denote the index and the second index will denote the jumps, right? So the total number of indices are n, and what are the total number of jumps that you can have? So that is also n, right? Why? Because if, let's suppose, at each index I make a jump of length 1, right? So then after taking jumps of length 1 1 1, I will be able to reach the last index with total number of jumps equal to the size of my nums, which is nothing but n, right? So the maximum number of jumps that I can get is n, right? And initially all the values will be -1, and then in our helper we will pass this DP vector, and then here we can receive this DP vector, right? Now here, before returning in the DP at the index end, comma, jumps, we will update it to mini, right? And here, before calling our recursion, we will check that if DP of ind, comma, jumps is not equals to -1, then return DP of ind of jumps, right? And then here we'll pass the DP vector. So let's run this. Now here we have reduced the time complexity to n square, but in the question the maximum size of our nums vector is mentioned as 10 to the power 4. So this approach will also give you a TLE. So we will have to optimize it more, right? So we will have to optimize to somewhere around linear time complexity, right? So let's think of that approach. So see here, initially we are at index 0, right? From index 0, I can either go to index 1 or to index 2. So then that means to these many indices, I can reach with the number of jumps as 1, right? I can reach index 1 and index 2 with the number of jumps as 1. This is denoting the minimum number of jumps, right? See, for index 2, I can reach directly from index 0. So that will take 1 jump. But I can also first go to index 1 and then to index 2. But that will take 2 number of jumps, right? Here, we are saying we will be able to reach index 2 in 1 number of jumps. So this number of jumps will be denoting the minimum number of jumps required to reach a particular index, right? So this is denoting that this particular range from index 1 to 2, we can reach these indices with the number of jumps as 1, right? Now from here, from index 1, the value is 3. We can go to index 2, 3 and 4, right? And from index 2, the value is 1, we can go to index 3, right? So the farthest that we can go from these many indices is index 4, right? So basically, my next range will be this, and to these indices, I can reach with the number of jumps as 2, right? So now we have got our answer that for reaching the last index, the minimum number of jumps required are 2. So this is going to be my answer, right? So let's take another example. If let's suppose my array is 2, 3, 1, 1, 2, 3, right? And the indices will be 0, 1, 2, 3, 4, 5. Now if you see, initially you are here, the number of jumps are 0, right? Now from this, you can at max go to which index? 2, right? So then that means this is my range now, and to these many indices I can go with the minimum number of jumps as 1, right? So this range we can denote with a L and R. L and R will denote the starting and ending of my range, right? So now from this range I will have to identify my new range, right? So basically that will be the farthest index where I can go. So from these two indices, which is the farthest index that I can go? So see, from here, we can either go to index 2, 3 or 4. Farthest we can go to index 4. And from index 2, farthest we can go to index 3. So out of these, the maximum index is 4. So then that means out of all these indices, the farthest that I can go is to index 4, right? So my next range will be this. Basically, my next L will start from the index just after R, right? And my R will be the farthest index that I can reach from my previous range, right? This will be my new range, and here the number of jumps required are 2, right? Now again, we have still not reached the last index. So we will create a new range. So from index 3, we can go to index 4 at max. And from index 4, we can go to index 5. So 5 is the farthest index where we can go, right? So our new range will be this. L and R both will be here. And the number of jumps required are 3. So then that means for reaching the last index, the minimum number of jumps required are 3. So with this, we are only going inside this nums array and we are identifying that for each range, for all the indices within a particular range, how many jumps are required. So whenever your range will be at this particular index, basically whenever R becomes greater than or equals to the last index, then whatever are the number of jumps that we have, that is going to be our answer, right? So let's look at the code. So first of all, let's take the size of the nums in n, and then we will create a variable jumps which will be 0 initially. This will give us the minimum number of jumps, right? And then for our range, we need a L which will be pointing to 0 initially, and an R which will also be pointing to 0 initially. Now we will run a loop that while R is less than n minus 1. Why? Because as soon as R becomes equals to or greater than the last index, we need to stop there and we need to return the number of jumps, right? So that is why R less than n minus 1. Now inside this, I need to find my new range and update my number of jumps, right? For updating the new range, I should know that from the current range, which is the farthest index to which I can go, right? So I'll take a variable maxi which will be 0 initially, and then we will run a for loop of I starting from L till I less than equals to R, right? And we'll do I plus plus. So now for all these numbers in this range, we will check the farthest index where we can go and we will take the max of all of these. So in maxi, we will update it to the maximum of maxi comma I plus nums of I, right? And then outside of this, we will update our new range. L will be R plus 1 and R will be equals to maxi, the farthest index where we can go. And we will increment our number of jumps by 1. And then at the end, we can simply return the number of jumps. Let's run this. Now here, although we have a loop over here for R, which is starting from 0 and going till n minus 1. And here again, we are running a loop of I from L to R. But the time complexity here is not n square, right? Although we are running this, but our R is also getting updated to the farthest index, right? So the indices would be visited only one time, right? So we can say that the time complexity of this code will be order of n and space complexity will be constant because we have not taken any extra space. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.